Hello, Geometors. I have a different setup here for the notes that I think I'm going to like better. It'll be a little easier for me to record and upload. But I am using my document camera and just writing on the same copy of notes that hopefully you were able to print or download. So you may want to pause the video as you maybe jot down these first two definitions. But we are on section 10.2. We are going to be finding arc measures. So we will define a little bit more about arcs and calculate some arc measures. So there are two definitions right now I'd like you to take down. The first definition is, what is the central angle of a circle? So the central angle of a circle is defined as an angle whose vertex is the center of the circle. I'm going to underline a few things while you guys jot that definition down. So it's an angle whose vertex is the center of the circle. An angle whose vertex is the center of the circle. So in this picture over here, the central angle here would be angle ACB. Okay, so angle C is the center of the circle, and it's the vertex of that angle. Okay, so that is a central angle. The second definition is hopefully a review, as I think you've probably heard the word semicircle before. A semicircle, it is an arc. Okay, it is an arc with endpoints that are the endpoints of the diameter. Okay, an arc with endpoints that are the endpoints of a diameter. Okay, so if I, over here, if I sketched, drew another circle, it's a pretty good circle actually, and let's draw a diameter through it. Okay. So the semicircle would be the arc. So I'm going to have to use a pencil because if I highlight, then I can't erase it and re-sketch on it. So if I draw over this arc, that's a semicircle. And so hopefully you know a semicircle is like half of a circle. Well, we have gone halfway around the circle itself. Okay, so that would be a semicircle. Okay, moving on to this next piece in the middle here. If the measure of ACB is less than 180 degrees, so let's actually use this picture up here. So if you look at, this is the measure, and this is talking about the angle. So ACB, now I can tell that that is less than 180 degrees. 180 degrees is halfway around your circle. So clearly this angle here, and actually if you look at this segment or line is like a straight angle. This doesn't make a straight angle. Okay, so I can tell that's less than 180. If that angle is less than 180, then the points on circle C that lie in the interior of angle ABC form a minor arc. Okay, so I'm going to continue to outline in red. From A over to B is considered a minor arc. Okay, so I'm going to write here that, let's see, I'm going to just label it right next to it. I'm going to write minor arc AB. And actually, it would be AB with like an arc symbol above it. Okay, that would be how you would write, instead of like segment AB would have like a segment bar, arcs have a little arc above it. Okay, so that's called a minor arc because it goes less than halfway around the circle. The opposite of that, the points on C that do not lie on the minor arc AB form what's called a major arc with the endpoints. So I would call, if I go the other direction, maybe I'll use blue. Yeah, we'll use blue. So if I go from A around through D and I stop at B, that's considered a major arc. So I'm going to put here A, D, B, and go ahead and put an arc above it. major arc. Okay, so major arcs go more than halfway around. They're going to be more than 180 degrees, and we'll get into some of that. Okay, so those are the two things we're going to look at right now. First of all, knowing the vocabulary. A minor arc would be minor arc AB. It went less than halfway around. Major arc goes around. And when you read the letters, you want to travel around your circle through these points. So A, then through D and stop at B. I would go A through D and stop at B. That's how you'd interpret that. Okay. This key concept, I know it's a little blurry. My printer, I don't know what it's doing, but it's printing it a little bit blurry on parts of it. So refer to your notes as you're looking at this. So this is talking about the measures of minor arcs and major arcs. Okay, so this says that the measure of a minor arc, so this is really our same diagram with arc AB. The measure of a minor arc is the measure of its central angle. So if I go like this, so angle ACB is a central angle. Okay, that's what we talked about here at the top. An angle whose vertex is the center is called the central angle. I always think of center as central. So whatever this angle measure here is, it's going to be equivalent to the measure of the arc. Okay, so there's two things going on here. I'm going to write here that the measure of angle ACB is equal to 50 degrees, but the arc is also equal to that. So then I'm going to change the notation. I'm going to write the measure of arc AB is 50 degrees. So one's an angle and one's an arc. Okay, even though they're the same measure, it really represents two different things. Now, actually, let me hold that thought. Moving on, the measure of the entire circle is 360 degrees. So if I went all the way around, the measure of a major arc is the difference between 360 degrees and the measure of the related minor arc. So for example, in this picture, if arc AB is 50 degrees, well, if there's 360 degrees all the way around and this section is making 50 degrees of it, then the rest of the arc, or that other major arc, is going to end up being 310 degrees. Okay, so that would be equal to the measure of arc. Now I want those three letters. I'm going to say it's A, D, B, and I want a little arc symbol above all of them. Okay, so they have that relationship where they should add up to 360, and you can name the major versus the minor. Okay, let's look at example 1. Let's practice that. All right, find the measures of the arcs. Find the measure of each arc in circle J, where segment KM is the diameter. All right, so this is really cutting my circle in half. Maybe I'll switch over to red. Okay, so your 125 is this angle right here. That's your 125 degrees. Okay, so arc LM. Let me go with pencil so I can erase. So I'm starting at L and I'm stopping at M. I want to know this arc's measure. Well, since LM, point L and point M are the endpoints of this angle, at the very top we said that the measure of this arc is equal to the central angle. So this is also going to be 125 degrees. Okay, all right, let me erase that. All right, if you want to, you can write 125 degrees next to that arc if you want, because sometimes we use that number later. Okay, arc LMK. So start with L, you have to go through M and stop at K. All right, so I'm basically going from here all the way around and stopping at K. I want to know that number. So I know that a part of it is 125 from before. Well, how much is M over to K? Well, that's the diameter. So this is a semicircle. That's half of the circle. So I know that that section is 180. So I'm going to take the 180 and add 125 to it, and that should give me LMK, the whole arc. So that would be what, 8, 9, 10. Looks like it would be 305 degrees. Okay. Now you will find too, if this is a major arc, it will be more than 180 degrees. If this is a minor arc, it will be less than 180 degrees because 180 degrees is sort of that middle ground. Okay, KLM. All right, so let me get rid of this mark. I'm going to try to leave the 180 and the 125. So K through L, stop at M. Okay, I have gone halfway around my circle, so that is 180 degrees. Okay? All right, I would like you guys to pause the video, and let me make sure on the next page. Yes, I would like you guys to try to do examples 1 through, or example 1 here. Go through 1 through 6, and then come back to the video. So pause right now and try those on your own. Okay, let me run through these here real quick. So AD, A over to D. Now you're going to do a little vocabulary here. So A over to D is less than halfway around. That is a minor arc. Okay, and then I want the degree amount. So because AD matches the central angle, it is also going to be 70 degrees. Number 2, AB is also less than halfway around. That's another minor arc. And so A over to B, I need to know this angle measure right here. Well, this is a line, or this is the diameter, I should say, which I know is 180 degrees. So what is left over so that all 3 of these add to 180? So if I take 180 and I subtract out 70 and I subtract out 50, it looks like I'm left with 60 degrees. So that is 60 degrees, which matches this arc. So I'm going to go ahead and label these. 60, we previously found 70, so 60 degrees. Okay, CD. So C over to D. Now, if you look at that, I've gone halfway around my circle. So it doesn't matter if I go this way around or the other way, because they're both going to be halfway around. So that is a semicircle, which is also 180 degrees. Okay, BDC. So start with B. You need to go through D and stop at C. So start with B. I'm going to go all the way through D and then stop at C. Okay, so what I could do is I could do it a couple of ways. First of all, this is a major arc. We are going more than halfway around. All right, so I could add 60 plus 70 plus 180 and get my answer. Or I could notice there's only one piece left over, and I know the whole thing is 360, and I know this arc is 50, so I could just subtract those two. So that should be, I believe, 310. If I do 360 minus 50, yeah, 310 degrees. Should be the same as 180 plus 70 plus 60. Okay, ADC. So A, let me try to erase here. I'm going A, oh, I have to go through C. So I have to go A through C, stop at D. So I could do the same thing I did on the last example. This time I'll add. So I know this one's 60, I know this one is 50, and I know that's 180. So if I do 60 plus 50 plus 180 gives me 290 degrees. So that is a major arc, and it's 290 degrees. 290 degrees. All right, one more, and I'm going to have to break this into 2 videos because I'm about to hit my time limit. So arc BC. So B over to C, I've already answered this one. So that's a minor arc. And I already previously got 50 degrees on that. Okay, so I'm going to stop this video and then have a second video pick up at adjacent arcs.